Okay, so this is, I think, the third part in this. What we're going to be doing today is setting up this little bit of UI here for the inventory. What I've done is I've tweaked the scene a little bit. There is now only one asteroid. This spawns in with 100 units of ore. I've been messing around with some extra graphics and stuff for the ship. And then in this, I'm getting a random asteroid because this is the only asteroid in the scene. It will always get this one. And then we've got mine, and I'm passing in the asteroid into that. So when I run this script, the number on the asteroid decreases, and then in the inventory we've got one item of ore, count is 1. I run this again, count is 2, count is 3, count is 4, and this will give all up to 10, at which point the inventory is full, and then it will throw an inventory full exception. So I think what I should really be doing here is using some sort of event system to trigger an event to say that the inventory is full, which it could then feed back into the user's control script for the ship. So yeah, we'll have to do a bit of a quick chill out, fast forward, me just putting all this together, and then I'll go through and talk about the details. So in the Unity editor, I've added this prefab here. This is the inventory panel, and this temporarily is linked to the ship controller, so that when the ship controller initializes, it initializes this inventory panel with the ship's inventory, which is what is causing that link when we run script. With that mine operation, it then adds 1 unit of ore into this UI. The inventory panel is a prefab. If I pop that open, basically what we have here is a panel, a scroll view. We've got an inventory row prefab here, and this has overrides, and I'm just using this to create the header. And what we're overriding is we don't have like the background colors and stuff. And in the scroll view, I've removed the horizontal scroll bar and just recolored this a little bit. So then in the inventory row prefab, this is a fairly simple thing. It has the inventory UI controller. These are the data binding serialized fields. So these point to the item key text and the item count text. Both of these are TextMesh Pro. I generally find TextMesh Pro is a little bit nicer to lay out and use. Their inspector is very well made. I do occasionally have some problems with it. I think that's probably because I'm not very good at using it, rather than it being a problem with TextMesh Pro itself. So the inventory row, we've got a horizontal layout group. These are the bane of my existence, layout groups in general. In a layout like this, where it's fairly simple, awesome, they work. If you're getting into more dynamic things where you want to change the size of objects based on their contents, and their contents contain more layout groups, like which then contain more nested layout groups, then it's a slow descent into insanity. I'm really looking forward to UI elements, which is the XML based approach, because that seems a lot nicer. I would much prefer to create my UI as XHTML and CSS rather than deal with layout groups. This is, yeah, it basically just lays out these things. Each of these has a layout element on them which sets its size, row width, row height, that sort of stuff. I don't know if I should do like a bit of a deeper dive video into using these things. I have a lot of trouble with them. Yeah, that might be a good video to do. Okay, so that's the general layout in the inspector. Inventory row, inventory panel, both prefabs. The inventory panel is instantiated on the main UI, and it's linked up to the ship temporarily. So probably the first thing to look at is the inventory item UI controller. This is attached to the row prefab. It basically has two TextMesh Pro text serialized fields which are linked up in the inspector, and then we've got public getters and setters, and these basically deal with the data binding onto the underlying UI. So in the case of item key, this is just a string, so it sets or returns the string value. In the case of item count, it's actually an integer, and that will pass the value in that text or add the value to string. On the inventory panel UI controller, there's a little bit more code here. We've got serialized fields for data binding the name of the object. As you can see, I'm not using this. I've got a game object which is linked up to the row prefab, and then a rect transform which is linked up to the scroll views content, and we're going to be using these two to spawn new items. I've also got a inventory controller that this one is linked to, and a list of item UI controllers, which is the items in here. The initialize method is currently called from the ship controller. As you can see, I've just basically added in a temporary serialized field for the inventory panel, and I'm initializing it here, passing in the ship's inventory controller. What we'll be doing in future is having, when you click on an item like an asteroid or a ship, it will initialize the inventory panel for that item. But for now, for the sake of testing it, we're just doing it for the ship. So this does basically a little bit of setup. It sets the controller, it passes in, or it uses up the items list, and it subscribes the on inventory changed handler to the on content changed event for the inventory. On inventory changed handler, this is just fairly simple. It just calls these two methods, and in the update manager, we're queuing this to be executed in the main threads update, because this can be called, and in fact is called, from a background thread, which means we can't access the destroy or the instantiate API from a background thread. So what we're doing is we're going to queue it up in the main thread and then execute it in the next update. So then we got clear items and add items. I'm putting these in as examples of how not to do it. So yeah, so I think this is a very sort of naive approach to doing it. We're basically clearing everything out of the UI, and then we're re-adding everything to the UI. Now, in itself, that's not particularly bad. What happens though is when we call destroy and when we call instantiate, adding and removing game objects causes garbage collection. So in this case, where this is only going to happen once in a blue moon when the inventory is changed, this is not a disastrous approach to doing this. It's kind of dumb, but it does the job. If this was going to happen every frame or multiple times per frame, this would cause a huge amount of garbage collection, which in turn causes a lot of lag. What it will do is it will queue up all of the garbage collection for like 4 or 5 frames and then execute it in one frame, and then that frame will lag. And if you're doing this for a large amount of game objects, that lag can be pretty significant. In an example, we were doing this with tens of thousands of game objects, instantiating tens of thousands of game objects. That in itself takes quite a long time, but then what happens afterwards is then the garbage collection for that instantiation causes a huge frame lag, like hundreds of milliseconds. So that is in general something you really want to avoid. Like 100 millisecond frame is not great, like obviously. what I wanted to do is I basically wanted to show this as an approach that works but is not optimized, and then what we can do is then optimize this approach. Probably the approach I'm going to use here is object pooling, where it will create a pool of rows that are hidden and then become active as they're needed. Additionally, instead of destroying and hiding rows, we're going to update an existing one. So instead of, if you have like one unit of ore in your inventory and you add another one, instead of destroying the ore row and then adding a new one with the value 2, we would then have some way of looking up the row in the inventory UI and then updating its value rather than creating a new game object to represent the change. Okay, so that's it for this video. What I'm going to do is in the next video, I think I'm going to go through and do all that optimization on this UI. I might do that off screen, but I will definitely have a video where I'm explaining the process and probably also do some benchmarking to see what the actual difference is. In this instance, it's probably going to be very minor. If we were doing this with, say, bullets or particles, where you're creating a new game object for every particle, that would lead to massive lag. So it might be worth doing the benchmarking side of that if we do particles or bullets or something like that. Yeah, so I'm just going to leave you this. We've got our script. We get a random asteroid. We call mine on the asteroid. Run the script, it adds ore to our inventory. Keep running that until it's full, and then we get the inventory full exception. I think what we should do is probably have some sort of indicator as to how full the inventory is. In fact, I might add that off screen. That would be quite nice to add. I've also got this exit button, which no longer does, well, which doesn't do anything because I've not done any, I wired it up yet. So yeah, the next steps would be to optimize the way this UI works and cover sort of in more detail that. Have it so that when you click on a ship, it opens up the inventory of that ship. If you click an asteroid, it opens up the inventory of that asteroid rather than just having the number. Yeah, so I think that's where I'm going to leave it. Yeah, thanks for watching. If you've got any questions, let me know, and I'll see you in the next episode. Cheers, guys. Bye. Have a good day.